Hello everybody, Mr. Gardner at the East Lab, and today we're going to have another lab day. Alright, today what we want to do is we're going to be doing Momentum Lab 1. So you should have this opened up, and you have it opened up in Notability, so then because you're going to have to fill in your data and do your calculations. Alright, so things you're going to need is this lab sheet, open in Notability, this video that you're watching now, the Momentum Lab video, and then a timer, okay? So you can use your iPad, you can use your cell phone, you can use whoever you can get, all right? Any device that has a timer would work. So you might have to borrow a brother or sister's, mom or dad, somebody's cell phone to use their timer. Also, you're gonna need the access to a calculator because you're going to be doing calculations. All right, so today what we want to do is we want to find out what is the relationship between speed and momentum. What effect will something, if it goes faster, does it have more momentum, less momentum, or does momentum not change? All right, so that's what we're going to find out today. Today what we're going to be doing is we're going to be rolling these three objects. We have a marble, and we have a ping pong ball, and then we also have a golf ball. All right, we're going to be rolling them down our track, okay? Because for momentum, there are a couple things you have to know. Momentum is our mass times velocity, all right? So the first thing we have to do is we have to find what is the velocity of each of these. What's the velocity of the marble? What's the velocity of the golf ball and the ping pong ball at 2 meters? So once we have the velocity, okay, or the speed, then we can find out what is the momentum of each, all right? And so the first thing we have to do is what we've done 1,000 times already. We've run these things down the tracks, we've timed them, okay? I will keep track of the time myself, but I also want you to keep track of the time with your timer that you have, either with your phone, your iPad, or somebody else's device, all right? So each of the distances is going to remain the same. Nothing changes there. The only variable in our experiment is what we're rolling, okay? So we will start with the marble first. And we are going to time it for 2 meters. All right, so let's get this ready. You get your timers ready. And same as before, I will say 1, 2, 3, go. When I say go, I will release it up here. Okay, this is 2 meters from right here to the end of the track. And I will say 1, 2, 3, go. We'll start our timers. And then when it rolls down and it rolls off the track, that's when you stop your timer. Okay, so get your timers ready. Here we go. Ready? This is the marble. Ready? 1, 2, 3, go. Stop. Okay. All right. Does everybody have that? Go ahead and now put that time right here. I'm going to go ahead and put my time. All right. You're going to put your data in there. Mine was 2.93 seconds, okay? Now, with this, we can calculate what the speed of the marble was for 2 meters. How do we do that? We have our distance divided by our time. We know our distance is 2 meters. I would divide that by my time, and you would put it right there. So you go ahead and calculate that right now. I'll calculate mine right now. Okay, I had 2 divided by 2.93. And that equals 0.682. So this is going to be, I'm just going to use the first two numbers behind the decimal, 0.68 meters per second. That tells me that that marble will roll a little more than half, almost 3/4, okay, between half and 3/4 of a meter stick in 1 second, okay? So, all right, now that we have our marble, let's then go to our golf ball. All right, so get your timers ready. We're going to do the exact same thing. Okay. All right, reset your timers. Now, if at any time that you mess up on your time, you don't start it in time, or you don't stop it in time, or something gets glitchy, you might have to pause or stop the video, rewind it, and do it again, okay? So here we go. Same thing, when I say 1, 2, 3, go, I'll let go, and then we'll stop it when it gets to the end of the track. All right, here we go. Ready? 1, 2, 3, go. Stop. All right, I got 2.67. You're going to write your time right here. Okay, mine was 2.67. All right, so to me, that's a little bit faster. okay? It went 2 meters in a faster time than our marble did. So let's see what our speed was. So I'm gonna do my calculations, you do yours. All right, so I'm gonna go 2 divided by my 2.67. 2 divided by 2.67 equals 0.749. So I'm gonna round that to 0.75, okay, meters per second. So you see here that this one goes 3/4 of a meter in 1 second. This one went less than that. So it tells me right now, my golf ball is faster than the marble. Okay, so now we have the marble and we've got the golf ball. Let's go ahead and try the ping pong ball. So let's go back to your timers again. Reset them. Okay. Same process. Here we go. Ready? 1, 2, 3, go. Stop. I got 3.30. You get yours. If you didn't get if you made a mistake, go ahead and redo it again. Okay, but I got 3.30. 3.30 seconds. All right, so I'm going to do my calculation. You do yours. Find your speed. Okay, so I have 2 divided by 3.3 equals 0.60. Actually, it's 0.606, so I'm going to go 0.61. Okay, meters per second. All right, now I can see. I can rank these from fastest to slowest. I know that this one here goes further in 1 second than the other two. So my golf ball was number 1. That is my fastest. Okay. And after that, then my marble, okay, comes in second. And then our ping pong ball comes in third. So now we know which of these is our fastest. And okay. Now, what we'll do is we're going to calculate then our momentum. Now, for momentum, you've got to have velocity, all right? Well, that's what we just did. We just did our speed or velocity right here. So I'm just going to take these numbers and I'm going to put them right down in here, all right? You do the same with your data. So my marble, I had 0.68 meters per second, 0.68 meters per second. For my golf ball, I had 0.75, so I'm just going to transfer it right down here. And the ping pong ball was 0.61 meters per second. All right, now what we want to do is we want to calculate the momentum. All right, which one has momentum? And momentum is just the relationship between mass and velocity, and that would be mass times our velocity. All right, so we have our velocity. What we don't have is our mass. We need to know the mass of each of the balls. All right, so let's go ahead. I've got the scale set up over here. All right, and let's see our marble first. Okay, you can see I'm going to go ahead and zero it anyway, just to make sure. Okay, and I'm going to set this in there, and I have 0.57. 0.57. So I have a mass of or is it 5.7?
5.7.
5.7 grams. Okay, if you're wondering, my lovely assistant is my son Tyler, and that's him right there. Sorry, I hope it didn't scare you too bad. All right, I know. People say he looks like me. Lucky guy. All right, here we go. The golf ball, all right, has a mass of 42.9. So I'm going to put that down here. We can see that that is about 8 times, a little more than 8 times more heavy, 42.9 grams heavier than the marble. Okay, and then our ping pong ball. What do you think? Is that going to be more or less than the marble? Okay, let's take a look. Go ahead. Oops, there we go. And we have 1.8 grams. All right, and that is a lot less than the other two. 1.8 grams. 1.8 grams. All right, now what you need to do is you need to calculate. You have everything you need for momentum, mass times velocity. So what you're going to do is you're going to multiply your 5.7 times whatever you got for your velocity here. You'll take your 42.9 grams, multiply that times your speed velocity right here, and 1.8 times whatever you have right here. I'm going to do the same thing with my data. I want you to do your data. Okay? So if you need to, go ahead and pause the video and you can do your calculations while I do mine. 5.7 times 0.68 equals 3.876. 0.87, and this is going to be grams per meters per second. Okay, and then I'm going to do 42.9 times my 0.75, 32.175, so 32.17 grams per meters per second. And then a ping pong ball, 1.8 times 0.61 equals 1.09. 1.09 grams per meters per second. All right, so now we know which is our fastest, and we know which one has the greatest momentum. All right, let's take a look. Which of these numbers is the greatest, is the largest? Well, that would be by far, that is this one here, our golf ball. Look at the relationship. The golf ball, okay, has the most momentum. It also happens to be the fastest. All right, what is the second one? What's the second largest number? 3.87, so that means our marble, and that means that our golf ball is third. Look at this, I want you to notice this. Okay, same order. So what does that tell you about speed? What effect does speed have on momentum? All right, that's what we're trying to figure out here. Okay, so now the next part that I want to do, okay, once you have all your information there, then we're going to go down to the third table, table number 3 right here, and we're going to get some more data. Now, this is what we're going to do. All right, we've already proved it by the numbers. We've already seen that the golf ball has the most amount of momentum. So what does that mean? Okay, an object that has more momentum is going to be harder to stop or harder to change direction. Okay, so we know that the golf ball has the greatest amount of momentum. It should be then, if we could test it, which would be harder to stop at a certain speed? The marble, the golf ball, or the ping pong ball? We're going to find out. Okay, so the first thing we want to do is we're going to do each one 3 times, and then we're going to find the average distance. All right, let me show you what I'm talking about. All right, on the floor here, I've got a track, okay, similar to what we have up on the table. But if you look down towards the bottom, okay, you're going to notice that I've got this cup, and I've got then the meter sticks to act as a gauge, all right? And what we're going to do is we're going to roll each one of these down for 2 meters, okay? And it's going to go into the cup. Now, when it hits the cup, it's going to push the cup backwards, okay? It's going to force it. So that momentum, so the cup is trying to stop the ball. All right, and so we're going to be able to tell then which one has the most momentum by how far the cup travels down the track once the ball hits it. Okay, so based on our information, we said, well, the golf ball has the most amount of speed. Okay, so it's got the greatest amount of momentum. Now, is that going to push the cup further down the scale than the marble, or will it push it further down the scale than the golf ball? That's what we're going to find out. Okay, so we're going to do this 3 times each. If you take a look at your data sheet, we're going to start with the marble and the cup. And so what we'll do is we will measure how far that cup travels once the marble hits it. Okay, and we're going to do that 3 times. And then we're going to find the average, okay, by adding the 3 distances, the 3 trials, and then divide by 3 to find our average distance. By that, we'll be able to see then which of these, the marble, the golf ball, or the ping pong ball, has the furthest average distance. The one with the furthest distance will have the greatest amount of momentum. All right, so all we have to do is we just need to find distance. We don't need our timers for this one. Okay, and I'm gonna have Tyler roll the ball, or nope, I'm gonna roll the ball. Okay, we're gonna start with the marble. We're gonna do this 3 times. We're going to record our data each 3 times. So you're going to still need your, it's okay. Don't be afraid. All right, here we go. There we go. All right, so I'm gonna start at the 2 meters. Okay, I've got my cup down here at 0. That's at the front of the cup right here, 0. And then we're gonna measure to see how far this marble will push this cup along our floor. All right, here it goes. Okay, 1, 2, 3, go. Let's see what we get here. All right, now the front of the cup, it went from 0, and let me get my other meter stick so we can figure this out. Okay, so you can see that it pushed it to 4.8. Okay, it went 4.8 centimeters. So now we're gonna set this up again. All right, I'm going to record my trial distance 1 of 4.8. You do the same on your data sheet. So fill this one in, 4.8, and this is centimeters. Okay, 4.8 centimeters. Okay, that's trial 1. Same thing, here we go again. We've got the cup set at 0. We're gonna roll this 2 meters. Here we go, exact same place. All right, not quite as far this time. That one is 4.4. All right, so 4.4. Set this one back at 0. I'm gonna write that one up here for trial number 2. All right, 4.2 centimeters. And now our third trial for the marble to see how far this will push the cup. Alrighty, here we go. 1, 2, 3, go. There it is, another good one. That's pretty close to what the, oops, sorry. That one was at 5 before I hit it. So that's really pretty consistent. Our numbers look pretty good, okay? So that one was at 5. So our first one was at 4.8. That's really close to 5. The second one was at 4.2. And our third one was at 5 centimeters. 5.0 centimeters, okay? We'll calculate the average distance when we're all done. So let's go ahead now and we'll do the golf ball to see what kind of effect that has. All right, here we go. 1, 2, 3, and go. Oh, holy moly. All right, we're going to the front of the cup and we want, that is 73.5 centimeters. All right, that is impressive, 73.5. Okay, let me write that down. I'm certainly getting my exercise today. 73.5. That was for trial number 1. Okay, let's do trial number 2. Here we go. Okay, 1, 2, 3, go. There it is. All right, wow, look at that. 75.3. 75.3. All right, very good. So our first one was 73. What was this one, Tyler?
75.
75.3.
3.
Right?
Sure.
I can't remember either. Okay, here we go. Our third and final one for the golf ball. All right. Scoochie this there, twist it a little bit. There we go. All right, here we go. 1, 2, 3, go. Woo! Look at that. Oh, that is awesome. All right, we have, that is 97, right on the nose. 97, wow. That one was way off. All right, way, way different than the others. You know what? We should do that one again. That's an outlier, okay? We always do this in science. You know that if we have one that doesn't really match up, all right? I would say, well, let's make sure that we have everything. Let's do that one all over. I'm going to erase my data. You do the same thing. We're gonna do trial 1, 2, and 3. See what kind of data we get this time, okay? Just for the golf ball, we'll keep, because these were very consistent, all right? We'll keep them. But since our golf ball was not quite so consistent, let's try it again. All right, here we go, 2 meters, and go. Uh-oh. Well, that was not gonna work. All right. That's what I love about science. Here we go. 1, 2, 3. There we go. All right, that's a good one. That's a good one. That is 91.8. 91.8. So 91.8 centimeters. 91.8. We'll write that one down. You record it on your lab sheet. 91.8. All right. Let's get our second tryout for our golf ball. Here we go. 1, 2, 3. That's more like it. Woo! All right, that's 99. Here's 100. All right, 101. That is 107. 107 centimeters. Wow! All right, that is carrying a lot of momentum. 107. Okay. That's still reasonable. That's still reasonable. 107. All right, and now here's our third and final one for the golf ball, hopefully. All right, 1, 2, 3. Oh, you know what? It ran off the track. Let's do that one again. Okay, here we go. 1, 2, 3. All right, well, you know what? It is what it is. We're going with 80. Yep, 80. 80 centimeters. All right, so write that down in your data sheet, and we will find the average, okay? All right, that's really interesting. 80. Okay, ping pong ball. What do you think? Is it going to have the most momentum? Is it going to have the least momentum? Or will it have no momentum? Well, we know if it's moving, it has to have momentum. All moving objects have momentum. Okay, let's set up our cup at 0. Here we go. 1, 2, 3. Well, that's not very far at all. All right, so if we take a look, we're going 0.9 centimeters is all. Wow. All right, 0.9. Interesting. Okay, 0.9. Not even 1 centimeter. Okay, not even 1 centimeter. 0.9, so that's just 9 millimeters. Okay, here we go. Trial number 2. Here we go. 1, 2, 3. Oh, oh. Here we go. Oh, hang on. Go. You know what? That one hit funny. Okay, that one hit the edge of the cup, so that's going to mess it up. Let's keep it consistent. All right, here we go. We're going to try that again. Here's trial number 2 for our ping pong. Go. There we go. That's better. All right. And that is 0.8. 0.8. All right. Well, we're getting consistent numbers at least. Okay. 0.8. There we go. All right, and our last one. Here we go. 1, 2, 3. There it is. All right, that looks about like the same as the others. I have got 0.7. 0.7. All right, now we have to figure out 0.7 centimeters. Okay, now we have to figure out our average for each one. So to find our average, we're going to add 4.8 plus 4.2 plus 5.0, and you divide those by 3. All right, now you use your data. All right, this should be the same data as what I had. So go ahead and do your calculations, 4.8, do yours, so that way I know if I screwed it up. 4.8 plus 4.2 equals plus 5.0 equals divided by 3 equals 4.6666, 4.66. I'm gonna round this to 4.67. All right, and so that's gonna be centimeters. So it has an average distance, it pushed that cup an average of 4.67 centimeters, all right, a little more than 4.5 centimeters. Okay, now the golf ball, all right, add those up, 91.8 plus 107.0. All right, I made a mistake, 191.8 plus 107 plus 80 equals, divided by 3 equals 92.9. It had an average of 92.9 centimeters. That's almost 1 full meter, all right, of 100 centimeters. Okay, ping pong ball. Now let's see, 0.9 plus 0.8 plus 0.7 equals, divided by 3 equals 0.8, 0.8. Is that what it is? 0.8, yep. 0.8. All right, what did we see then? All right, what do we see with all this? Now, remember what we said before, okay? The golf ball was the heaviest, had the greatest amount of mass, and then the marble, and then the ping pong ball, all right? If we take a look, this one has the most amount of, it pushed the cup the furthest distance, so it tells us it had the greatest amount of momentum, and then this one, and then our ping pong ball. Look at that, it's the exact same way that we had for our mass, for our momentum up here, all right, the exact same thing. We said that this one, okay, up here, we said that our golf ball had the most momentum, all right, our marble had the next most momentum, and then our ping pong ball had the least. Same thing here. Interesting to find out, golf ball has got the greater amount of mass, marble has the second amount of mass, ping pong ball has the third amount of mass, all right? And so that tells us a couple different things. It tells us that mass has a direct effect on momentum. The greater the mass, the greater the momentum, all right? Also, we found out that the speed, okay, our golf ball was the fastest, our marble was the second fastest, ping pong ball was the slowest, all right? So it also tells us that perhaps speed also has a relationship, has a direct effect on momentum. All right, this is what you need to do. You need to fill in now this part right down here. You need to answer these questions on your own, okay? After I explain this, I'm turning this off. You need to finish it, and then you submit it to Canvas, okay, for your points. So you look at table 3, that's this one here. Which object made the cup travel the furthest? All right, we know that. Why do you think it made it travel the furthest? Give me an explanation. Based on your data in table 2, what effect does mass, okay, here's table 2. Here's our mass. What effect did mass have on momentum? Write your answers, go ahead and submit that, and then I'll see you tomorrow. Thanks, folks. Bye.